Hello students, here we go on the 1.7 study guide. So let's take a quick look at these new key terms that we're going to be going over, and remember that these are a review from Math 1, so hopefully they sound familiar. Arithmetic sequence is a sequence of numbers in which the difference between any two consecutive terms is the same. It means when we're adding or subtracting the same number. So for example, from 2 to 4 to 6 to 8, you might notice that that is growing at a rate of +2 every time. So that's what, if we're adding a constant rate every time between those consecutive numbers, then yes, that is an arithmetic sequence. How about this one? Going from 50 to 40, 40 to 30. You may notice that that is subtracting by 10 every time. Since it's subtracting at a constant rate, that is an arithmetic sequence. We're going to be asked in this assignment to continue these sequences, find the next three terms, and we would continue the pattern. The common difference is the constant value between any two of those consecutive numbers in an arithmetic sequence. So the common difference is the +2 in this one. The common difference is the -10 in this one. It's also known as the constant rate or the slope of the equation. A common ratio is the constant ratio between any two consecutive numbers in a geometric sequence. It's also known as the multiplier of a sequence. Exponential decay. This is a situation in which a quantity decreases by a common ratio at regular intervals. This is known as a decreasing curve if we were to graph and see the line. Exponential growth is the opposite of that. It's a situation in which the quantity increases by that common ratio or multiplier at regular intervals, and that would look like an increasing curve on a graph. Finally, a geometric sequence is a sequence of numbers in which the ratio of any two successive terms is equal, multiplying or dividing by that same factor each time to the previous term. So if I jump from a 4 to an 8, from an 8 to a 16, from a 16 to a 32, you may notice that I'm multiplying by 2 each time. 2 is the multiplier or the common ratio in this geometric sequence. From a 100 to a 50, from a 50 to a 25, you may notice that that's going down by half. The multiplier in this geometric sequence is 1/2. Because of this word consecutive that comes up a couple times in this, I did put a quick reminder up here. Consecutive numbers are numbers which follow each other in order without gaps. So from smallest to largest, 12, 13, 14, and 15 are consecutive numbers, just as a quick reference. 2 cash prizes grow over 6 days. The value of prize A is 2 times the number of days, while prize B is 2 times the amount the day before, starting with the first day. These graphs and tables show what will happen over 6 days. Even though both prizes grow for much longer, this information can still help you determine which prize offers the biggest payout. So here we have prize A and here we have prize B. Notice one is linear and one is exponential, or one is an arithmetic, adding by the same number, and one is a geometric. Let's go see what they're asking us about it. Based on the graphs and tables, which prize offers more money? Prize B offers more money because it is growing at a faster rate. Did you notice that the Y values for prize B were increasing more quickly than the values before prize A? Yes. If you look carefully at each of the tables, can you determine how each of the values is increasing? And after identifying that pattern in the table, you can use it to extend the sequence. So jumping from a 2 to a 4, from a 4 to a 6, etc., we notice that this one is increasing by 2. Every time. We always want to check that change in Y as well as the change in X on the other side. Notice it is only increasing by 1, so we're good to go. On this one, it goes from 2 to 4, 4 to 8, 8 to 16. This one is increasing by a multiplier of 2. It's doubling. And also for a change in 1 on the left. For prize A, what is happening between each term? It is the same number added or multiplied. Yes, we are adding 2 each time to the previous term. Find the next 4 terms following the sequence pattern. So from the 12, we would say it goes to 14, 16, 18, and 20. For prize B, what is happening between each y term? It is multiplying by 2 each time to the previous term. Find the next 4 terms. 64 goes to 128, 256. Then that even gets too big for Ms. Sanchez to be sure about it, so she grabs her calculator. 256 times 2. And then 1024. The graphs and y values of these functions have special names. A blank is a sequence of numbers in which the difference between any 2 consecutive terms is a constant, called the common ratio. Well, this is known as our arithmetic sequence. And then a geometric sequence is a sequence of numbers in which the ratio between the 2 consecutive terms is constant, but this one's called the common ratio. Oops, sorry. This last one was supposed to be common difference. Somebody probably caught me. And this one's our common ratio for the multiplying. Of course, not every sequence has a common difference or a common ratio, so not every sequence is arithmetic or geometric. When you find a blank, you know you have a blank. Just choose any numbers in the sequence and subtract the number immediately to its left. Do this several times to be sure you've found a common difference. When you find a common difference, you know you have an arithmetic sequence. Of course, not every sequence has one, but so let's check this out. 13 minus 9, 4. 17 minus 13, 4. 21 minus 17, 4. The common difference is 4, so this is an arithmetic sequence. When you find a common ratio, you know you have a geometric sequence. So notice from the 3 to the 9, from the 9 to the 27, that you're dividing. If you divide 9 divided by 3, or 27 divided by 9, you get the same common ratio. The common ratio is 3, so you have a geometric sequence. But what if you're not sure what kind of sequence it is? It's important that you know how to look at a sequence of numbers and determine what kind it is by testing for a common difference or a common ratio. Look at the problems below and determine whether the sequences are arithmetic, geometric, or neither. If it's arithmetic, find the common difference. If it's geometric, find the common ratio. So right here, if you've got negative 4.1, negative 1.6, 0.9, and 3.4, you're looking to see what that common difference or common ratio might be. So let's try subtracting. 3.4 minus 0.9. That's a difference of 2.5. Then we say 0.9 minus a negative 1.6. And this calculator doesn't do negatives. 0.9 minus a negative 2.6. 1.6. And that gives us the same 2.5 that we just got when we subtracted the other. This one is an arithmetic sequence because the common difference, which we're going to use a lowercase letter d, equals 2.5. That's how it's growing each time. Go from 1/2 to 1/3, from 1/3 to 1/4. This is not adding by the same number or dividing by the same number. So this one is a neither. From 48 to 36, 36 to 27. This one's going down by 12, going down by 9. It is not a constant, so let's go ahead and try dividing. Let's try 48 divided by 36 and 36 divided by 48 divided by 36 is a 1.3, and 36 divided by 27 is a 1.3. So this one does have a common ratio. So this is geometric. And let's look at that ratio again. I'm looking at a 0.75 ratio. So for a common ratio, we're going to use little r equals 0.75. You could also call that 3/4. So from a 6.2 down to a 4.6, 4.6 to a 3. Let's go see what the difference is in that. Down 10 minus a negative is a change of 1.6. And then we'll do the negative 4.6 minus a negative 3. And that's also a change of down 1.6. So this one is arithmetic. And the common difference is negative 1.6. Oh, I guess that's what this little line was for over here. All right, from a 1 to a negative 1, back to a 1, back to a negative 1. This is a pattern I can recognize, but is not arithmetic or geometric. From a 1 to a 4 is plus 3, plus 3, plus 3. So this one is arithmetic. It has a common difference of 3. From a 1 to a 2, from a 2 to a 3, from a 3 to a 5, from a 5 to an 8. This is adding 1, 1, 2, and 3. This is neither, and this has nothing then. From a 2 to a 10, from a 10 to a 50, from a 50 to a 25, do you recognize the multiplier there of 5? So this is geometric. It's being multiplied by a ratio of 5. If you don't see the 5, we just take 10 divided by 2 is 5. 50 divided by 10, 5. 250 divided by 50, 5. We can get that by dividing. When the y values of a function are an arithmetic sequence or a geometric sequence, it says something important about remember the radio size problem from earlier? See if you notice a relationship between the y values and the shape of each of the graphs. Prize A is an example of a arithmetic sequence. Prize B is an example of a geometric sequence. Both are increasing functions. The growth of prize A is arithmetic, which computes to linear as a function, because we know that because it looks like a line. There's another big clue. Look at the y values. What kind of sequence do they form? The sequence has a common difference of 2, therefore it is an arithmetic sequence. In fact, all arithmetic sequences have all linear functions have y values that form arithmetic sequences. But what about functions whose y values form a geometric sequence? These are also special. They're called exponential. A situation in which a quantity increases so real quick, a situation in which a quantity increases. I hope that's reminding you of this vocab word. When I go way back up to the top and I look at this exponential growth and decay, a situation in which a quantity increases by a common ratio at regular intervals. There's our definition coming right into play here. A situation in which each quantity increases by a common ratio at regular intervals is called exponential growth. In a situation in which a quantity decreases by a common ratio at regular intervals is called exponential decay. Prize B is an example of exponential growth. Prize money grew. For linear functions, the slope is the common difference. The y values form an arithmetic sequence. When the common difference is greater than 0, the linear function is increasing when the slope is positive. When the common difference is less than 0, the linear function is decreasing when the slope is negative. For exponential functions, the y values form a geometric sequence. When the common ratio is greater than 1, it's exponential growth. When the common ratio is greater than 0 and less than 1, it's exponential decay. That means it's going to be a fraction. Determine the types of linear functions. There's linear increasing, linear decreasing, exponential growth, or exponential decay. So going from 1,000 to 100, 100 to 10, and 10 to 1, we're dividing by 10 every time. Something that's getting smaller exponentially is going to be exponential decay. 4 to an 8, 8 to a 12, 12 to a 16, that's adding 4 every time. That's linear increasing. 27 to 9, that's subtracting 18. 9 to negative 9, subtracting 18. That's linear decreasing, going down by a constant rate. And finally, going from 3 to 15, 15 to 75, that's multiplying by 5. That's exponential growth. And that's the end of the study guide.